you already know, there are different ways of finding zeros on a continuous function. With this graph, I will explain to you how to find the approximate zero of this function using Newton's method. Newton's method is an alternative technique to finding zeros in a given function. The technique is accomplished by using tangent lines to make an educated guess to where a graph of a function approaches the x-intercepts. When contemplating the usage of Newton's method, consider these important points. Consider that the function f is continuous on a closed interval from a to b. F of a and f of b must also differ in sign of positive or negative. This must be proven with an immediate value theorem. The given function has at least zeros within the a and the b interval. In Newton's method, the formula for this would be x sub n plus 1 equals x sub n minus the function itself divided by the derivative of the function. And when you pick x sub n1 is going to be your first point picking on your graph, which is going to set you up to use a function for the tangent line in order to find x sub 2.
Okay, so once you get your answer using your first random number, you plug that answer into your x sub 2 because you want to find x sub 2. So that would be the answer from x sub 1 minus the function divided by the derivative of the function, and that would give you this tangent line. And the next thing you want to do is find x sub 3, and this is going to be your closest approximation to c. So you would take the answer of x sub 2 and plug it into your formula and subtract that. You would subtract x sub 2 from the function divided by the derivative of the function. Okay, so let's look at this problem. F of x equals 3x squared minus 10. What you want to do first is find an initial random point. So we picked 3. So you would plug in 3 into this formula. X of n minus the function divided by the derivative of the function. So we have 3 minus 3 times 3 squared minus 10 divided by 6 divided by 6 times 3. So our x of 1, approximately, we got 2.056. Once you get your first approximation, you then plug it in to your formula again. So we want to find x sub 2. So 2.056 minus 3 times 2.056 squared minus 10 divided by the derivative of the function, which is 6 times 2.056. Our x sub 2 approximation is 1.838. So lastly, we want to find one more point. So we would use the answer that we got from x sub 2, and we would plug it in to the formula again. And that would be 1.83 minus the function, which is 3x squared minus 10. So you would plug that in. 3 times 1.838 squared minus 10 divided by the function divided by the derivative of the function, which is 6 times 1.838. And this approximation is 1.75. X sub 1, x sub 2, and x sub 3, these all should give you approximation to C, and this would be your desired point.